Well, hello. You're back at math again. I'm glad to see that. The first lesson didn't scare you away, or the fact that you have no choice and have to do math the rest of the year kept you here. Either way, I'm glad to see you back. So let's get our goal written down on our notes page, please. Make sure you have today's date and page number at the top. Don't forget to stop and pause and make sure you have all that right after this. So what are we doing today? Well, we're going to be able to know how to use an algorithm for adding, subtracting, and multiplying, and identifying the parts of an expression. So you're filling out your gas sheet. Think about that for your understanding line. Do you even know what the word algorithm means? That might affect what kind of score you're going to put down on your gas page. So when you're ready, we'll move on. All right, so today's warm-up is pretty easy. None of it says estimating, so all this, that's that bell, all this is going to be done in your notebook. It does say show your work, so just write out the problems and give me the answers. Come back when you're ready. We'll see how you did. Good luck. These are the correct answers you should have had. 31, 65, 22, 9, 32, 75, and the bottom one may have confused some of you. That means division. 24 divided by 6, or 24 divided by 4 is 6. 24 divided by 6 would have been 4. So these should have been pretty easy for you. I bet a lot of you got it done in a minute and a half, probably even less. Why? Because you've been practicing these things for a few years. And you know that there's a pattern that you follow every time you write the answers. It's a pattern, and that pattern is the step-by-step order in which you work through your problems. We call that an algorithm. So let's get into our notes for today. All right, so an algorithm, that's what we're going to work with today. That was that word in the goal that probably a lot of you were like, huh? But now you know. So what is an algorithm? Well, we'll start our notes off. Let's use red. An algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer or your brain. Now we can shorten this down for your notes part. An algorithm is a process or set of rules to be followed, okay, step by step to get what you need. Now you're going to use algorithms to solve equations and expressions. So what's the difference between an expression and equations, or an equation? Expressions, okay, these are our notes here. Expressions are mathematical sentences that consist of variables, numbers, and operations. Let me give you an example of an expression, a real simple one. It's 3 plus x. 3 plus x. So how is this an expression? Well, there's no equal sign. We just have to solve the sentence. So what do we have here? Well, the 3 is an example of a number. And you're probably like, well, duh, I know that. Okay, I got to make sure you understand this stuff. X, we call this a variable, because x can be any number that needs to be there to make the sentence correct. And what do we call the plus symbol? Well, this is one of the operations. Okay. We'll get into order of operations later. We know that operations have to do with what the symbols tell us. If you ever see something in a brackets or parentheses, you do that first. You see exponents, that's an operation. Adding, subtracting, multiplying, dividing, those are operations as well. Okay? So expressions would be something like this. The other thing that we're going to look at are equations. So I'll go back to red. Star it. Equations are mathematical statements that consist of a sequence of symbols that are split into two sides that are equal. All right. This is probably one you've seen before, something real simple. And let me give you an example of an equation. How about we'll stick with 3 plus 4 equals 7. This is an equation because we have an equal sign, so it's split into two different sides. And we know that 3 plus 4 gives you a value of 7. So really, it's the same as saying 7 equals 7. And because it's equal on both sides and it's split into two different sides, showing different ways to give you 7, that's correct. Another way we could do this could be 3 plus 4 equals 6 plus 1. So this side is 7, and this side is 7. So this statement would be true as well. It's an equation. Everything balances on both sides. And finally, I'm going to give you another example using a variable. So you could have something that looks like this. 3 plus x equals 8. Now, 3 plus x is the same as 8. The only thing we don't know is what is the value of x. We're going to learn to solve the value of x as we go through our lessons this year, but x would be what? 3 plus what gives you 8? That would probably be 5. You know that 3 plus 5 gives you 8, and that's how you can balance it out. You say x equals 5. This also works. Okay? So these are just examples of expressions and equations, and you use algorithms, step-by-step processes to solve them. Make sure you have this down. I would encourage you to put down these examples as well before moving on. And when you're done writing these notes, I'll see you in the next slide. All right, before we get into actually solving some of these, I have a few more notes for you. I know there's a lot of notes for this lesson. You'll get over it. This is probably one of the heaviest note lessons we have all year because there's a lot of stuff you need to know since we're going to be using this all year. So you're going to want to make this table in your notes. Wait till the end because I'm going to talk through some things. You might want to listen to it. So addition, subtraction, multiplication, and division. These are parts of expressions or equations. And I have all the words written down. Now some of these words you probably heard. Some this would be the first time. Now I know you know that for addition, sum is an answer problem. You knew that already. You knew difference means the answer to a subtraction problem. You know that product means the answer to a multiplication problem. And you know quotient is the result of a division problem. Those are pretty similar. But did you know what we call the numbers in an addition problem? If we had the problem 3 plus 6, did you know that these are called addends? 3 and 6 are considered addends. When you add them together, it gives you the sum of 9. So the sum here is 9. So that's how the parts go together. Probably something you've never heard before. Now subtraction, let's go with, we'll keep the same 3 numbers. Why don't we do 9 minus 3 equals 6. Now here, the first one is called the subtrahend. It's a quantity or number to be subtracted from another. So you're going to be subtracting away from this number. And a minuend is a quantity or number from with another is to be subtracted. Okay, so we know that those two numbers when subtracted are going to give you the difference of 6. But which one exactly is the subtrahend and which one is the minuend? So how it always goes is minuend minus subtrahend. So the minuend would be 9 here, and the subtrahend would be 3. Okay, so minuend means you're going to be taking something away from it. Subtrahend is what you're actually subtracting away. Now multiplication, this one you already know product, and you probably heard factors before. So we'll pick the factors of 3, we're going to write it like this, times 2 equals 6. Well, the product is the answer, that's 6. But the factors, both numbers are considered factors. Now if you look at multiplication and you look at addition, you'll see they both have just one name for them. And that's because they can flip-flop. You could do 2 times 3 and get the same answer. With addition, we could change it to 6 plus 3 and still get the same answer, 9, or 6 for multiplication. Subtraction and division, these are the ones that have all these crazy different parts. Every single part is different. For division, I'll stick with red. Let's say I had 10 divided by 2 equals 5. Well, we already know the quotient is the answer, which is 5. But do you remember which one the dividend and the divisor would be? The dividend is the 10. It's the number to be divided. And the divisor is the 2. That's the amount of groups you're going to break up the dividend into, which gives you the quotient. So I want you to have these down. You probably want to put down the examples too because you can see exactly what parts they are. So now you know all the parts of adding, subtracting, multiplying, dividing. Pause the video. Make sure you have the notes down before moving on. All right, so what are we going to do today? Well, I want you to be able to look at some algorithms, addition, subtraction, and multiplication. So you can see how people put together algorithms, the step-by-step process. It's the same stuff you use, but I want to make sure you identify it. So you're going to be doing, you're going to be going to Learn Zillion. You're going to have to type in this code. Actually, let's use this. You have to type in this code, and then there are 5 things that you're going to have to search for. What the lesson is about, what mistakes do you need to avoid, what are 2 or new interesting things from the video, write your algorithm for this operation, and create an example. You're going to do the same for subtraction and multiplication. Now to make it easy, I want you to go to the next page in your notebook, and you're going to turn your page landscape style. So you're going to take your notebook, which is up and down, and turn it sideways. And I want you to make this chart in the fill the entire page, and you're going to be filling this in. So what I did is I put the little codes up here for each one of them, and in here you're going to tell me what the lesson is about. At the beginning they tell you a goal. Write down the goal. What mistakes do you need to avoid? Find what is usually a tricky mistake for these steps that people goof up. They do talk about in each video. You have to come up with 2 or new interesting things from the video that you found. And then they're going to give you the algorithm. I want you to put the algorithms here. And then they'll give you an example of using the algorithm. You'll put it here. So let me show you what this looks like. I'll get rid of this for now. So we know that it's going to be LZ3122 for addition. So you're going to go up to Moodle, go back to Moodle, or open this back up. You're going to click on Learn Zillion. Now up here in the top, you'll see this little magnifying glass. If you click on it, in here you'll type, and it doesn't matter if it's uppercase or lowercase, LZ312, LZ3122, 3122. And when I hit enter, this pops up. All right, if you get one of these things, let me know. I'll work with you. I'm just going to sign in through Google. There, I'm done. So here, you're going to click play, and you're going to watch the video. So as you click play, you'll see that the video starts. And right there is what your lesson is about. You can see in this video, they're going to start putting together an example problem. That is your algorithm, your example there. So you're going to watch the video through, and then you're going to fill in the chart. Okay, fill in the chart. When you're done then, you type in this code, you do subtraction, you do this code, you do multiplication, and you're done. Okay? So take your time going through these. Ask me if you have any questions as you work through them. And when you're done, you're going to come back to the video and we'll see what to do next. Okay, now that you've finished all 3 videos and you've filled in your chart, probably looks nice and pretty. Not like this one. Yours looks full. You're going to want me to check this over, and then that's going to be your quiz, basically. As long as that looks good, you can then get this worksheet from me. It will be a worksheet review from our lesson 1.1 on estimating. You'll be doing that as homework. All right, you finished your second lesson. Hopefully this one wasn't too bad. I know there were a lot of notes, but you got through them all right. So we'll see you next time, and good luck on your worksheet, and thanks for hanging in there.